Hey, what's up, guys? This is Sheng here. So this time, 1771. Maximize palindrome length from subsequences. So you're given like two strings, right? Word one and word two. So you need to construct a string in the following manner. So choose any subsequence from word one, and then choose another subsequence from word two. And then you need to concatenate those two subsequences together to make the new string. And among all those kind of possible scenarios, we need to return the maximum length of the new string that can form a palindrome, right? So for example, we have some examples here, right? So let's say we have CACB, CBBA. So the longest we can get is this one, is AB and CBA, okay? So this is another one, right? So we have three here. So this is the one we should be take additional care here. Basically, the reason we have 0 is because so we have like a palindrome in this one, which is 2, right? So AA is a palindrome. Same thing for this one. There's also a length of 2 palindrome here. But the reason we have 0 here is because we have to find any subsequence from both the we need to find two subsequence from both word 1 and word 2. So for this example here, if we pick a number or a letter from both word 1 and word 2, we cannot make any palindrome string. That's why the answer is 0. Okay. So we have some examples here. So that's a 1000, right? I mean, so for this kind of problem, the if you try to like basically list all the possible scenarios from all the subsequence from A, from word 1 and word 2, and then you just try to check if the new string has a palindrome. That will be too slow, right? Because that's going to be it'll TLE, right? So the way we should solve this problem is the you guys pretty much all know about how can we calculate a longest palindrome, right? The longest palindrome, a longest subsequent palindrome for a given a string, right? We can use like the DP, right? Dynamic programming to calculate that. Basically, the DP I and J, right? DP I and J means that the string from I to J, right? From index I to index J, what is the longest palindrome? What is the longest subsequence as a palindrome, right? From I to J. So this gives us like a hint to solve this problem. So if we can concatenate this word 1 and word 2 together, so let's say we have a new word equals to word 1 plus word 2. Okay, so with the new word, we can use this DP technique to calculate all the longest palindrome for all the possible start and end point. So the only problem we need to solve is that how can we make sure basically the palindrome has both some string or letters from word 1 and also from word 2. Okay, so assuming we have this, right? So actually all we need to do, there's a trick here. We can simply try we only try because the I is the starting point, J is the ending point. We just need to enumerate all the i's in the range from, let's say we have n1 and n2, right? So let's say we have this kind of string here, right? So let's say this is the word, this is word 1, and this is word 2, right? So actually, all we need to do is that we just need to enumerate all the index from both from word 1 and word 2. Basically, which as long as we can make sure the I is within the range from 0 to this n1, right? And then the j is within the range of from this n1 to n1 plus n2, right? Then because as long as we can make sure the I and j is within this range, then we know, okay, that's gonna be we can find like the we're sure, right? So there will be a like subsequence, right? And then with both the letters from word 1 and word 2. So which means that we just need to enumerate all the possible combinations, right? For for both the I and j within this two range here. And as long as the word this letter, the word 1 word 1 I and word 2 j are the same, right? So if they are the same, and then we can just use the similar logic uh, when we to calculate dp here, right? Basically, if the word 1 I and word 2 j are the same, then we know, okay, we need our final answer for this kind of combination combination is going to be 2 plus the dp of this I plus 1, and then this kind of a different one, a different index, right? Because this one is j, right? So we're going to be j minus 1, j minus 1. Actually, this one should be n1 plus j minus 1. n1 plus j minus 1. Okay, right? So because here, I mean, as long as since we're saying that, you know, if the word 1 I is equal to the word 2 j, it means that, okay, basically we know that there has to be a palindrome, right, between I and j because they are the same. Even though there's nothing in between, right? They're gonna form a more palindrome. Just given this, only these two letters can form like a palindrome with with length 2, right? And then by subtracting these two, and all is left is that we just need to we can simply use to pre-calculate dp I plus 1 and this like n1 plus j minus 1 to find the if there's any additional palindrome in between these two numbers. Okay, cool. So I think that's basically the idea here. I mean, okay, so to do the codings, right? So we have a length of word 1, length 2, it's gonna be a word 2, right? So we have word equals to word 1 plus word 2, and then we have n equals to length of word. So for dp, right, 0, and then for this thing in range of n, right? So that's how we initialize this dp for this combined word here. So to start with, right, since in range n minus 1 minus 1 minus 1, okay. So again, I'm doing this one from the end to the beginning so that I can just use I and j to represent start from I and end with j, right? So j is going to be from I to n. Okay, I mean, you can do it in the different order, but this is how I do it, right? So basically, if the words I equals to words j, right? So if that's the case, um, if j minus I is smaller than 2, it means that, okay, so there's no need to, basically there's only either one or two letters, right? So in this case, we can simply do this ij equals to j minus I plus 1, because that will be the answers. Else, if there's more letters in between, then we know that we can just do this dpij 2 plus dpi plus 1 and j minus 1, right? This is a remove by after removing this I and j, right? So if there's anything right in between, then we're gonna accumulate that. Okay. Else, right? So if the I and j is not the same, then we know, okay, we have to basically look for the max of dp I plus 1 j or the dp I j minus 1, right? So that's how we calculate the longest palindrome, right? For all the possible subsequences. So now we just need to, for I in range of n1, right? So we're making sure that's going to be the value, right, for the first subsequence, and then for j in range of n2, right? So if the word 1I equals to the word 2j, right? So we only need to do this because we only if and only if the I and j's are the same, then we know, okay, there's like, then it's time for us to calculate the the values or the substrings, right, in between. Otherwise, there's no need to consider because there won't be a palindrome, right? Because the palindrome has to be basically the left and right. So here we're saying that, I want to know, starting with I and ending with j, what is the longest palindrome, right, for that. And so I think from my case, the let's say we have some like two. This is a word 1. This is the word 2, and so the value is going to be answer equals to the max of answer dot 2 plus dp I plus 1, and then n1 plus j minus 1, right? So this one means that, the since the remember the dp, the length of the dp means the combined word, but here I is the I, but for j we're only looping through the second half of the string here. So for I we can just use the I plus 1, but for the j, right, we have to convert this j to the to the length in terms of the combined word. That's why, the length of the first one is n1, right? So, and we just need to do a plus j. So that'll be the actual index for the ending point, and we do a minus 1 because we need similarly as this one, right? Because we're removing or moving this one away from the current string. That's why we do n1 plus j minus 1. Yeah, because this one will give us the biggest, the longest subsequence in between, right? And actually, I'm thinking about maybe there's a corner case maybe we need to consider here. I mean, since we're moving this one closer from both left and right side, so for this case, what if I is this one, j is here? I think in this case we might for this one, if the j is next to I, so for this one I guess this one should be equal to 0, right? Because there's no need to do that. And Yeah, so this is what I mean. Basically, if the I is equal to n1 minus 1, right, and j equals to 0, so for this one, I think the answer should be the max set of answer dot 2, right? Else we do this, right? So in the end, I can simply return the answer. Yeah, I think that's it, right? If I run the code, accept it. Yeah, so it passed, right? Let me see. Actually, you know what? So maybe for this part, I see. So we don't have to separate this one here. So basically, so if this is the case, right? So I will move to here, and J will be moved to here, right? So which means in this case, the start is greater than the ending point, right? So and for that case, you know, I think the DP, since we initiate all the elements with 0, so for the case that I is greater than J, so the value for that DP will be 0. So I think that's exactly what we want here. So which means that we don't have to separate those two scenarios. We can simply use this one, because when the I is greater than the second part, right? Then this one will become to 0. Yeah, I guess this will just work. Yep. Yeah, and time space complexity, right? So we have word 1 and word 2 here, right? So that's gonna be basically that, let's say the m times m plus n then of square, right? That's gonna be the time complexity, because the total length is m plus n, and then to loop through the other possible subsequences, right? Or all the possible start and end events, we have a O(n) square. And similarly for this for this one, this is also like a O of, this one is like O of the this one is like a n square, right? Or m square. Yeah. Right. So I think that's it for this problem. You know, it's not that difficult, right? It's just that you have to be able to figure out. I mean, it's going to be hard to calculate the subsequence separately for both the left and right part. So why not just combine them together? Because after combining those two words together, we know we have a way of calculating all the longest subsequences for all the start and end point. And with that, we just need to do a little bit trick to make sure we only consider the answer when the palindrome, right, starts across two parts. So the way we do it is that, you know, we just need to find the starting point and ending point for that for that palindrome, and then how can we make sure the palindrome starts in the first element, in the first word, and end in the second element, right? So as long as we have two letters, right, that equal to each other in both the word 1 and the word 2, and then we know, okay, so there must be a palindrome, right, in between, and then we can utilize the pre-processed DP array to help us quickly calculate the palindrome right in between. Cool. I think that's everything for this problem. I'll just stop here. Thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.